Hi, Mr. Worley back here with video number 2, section 6-2. You might be wondering, what should I write in my notes? Well, previously we talked about what are chemical equations. If it's in bold, you might want to have it on your notes. Also, you might want to have in your notes the basic formula for a reaction, which is reactant plus reactant arrow, which means yield. I'd like you to know that the arrow means yield or produces product plus product. And be able to recognize the difference between a symbol, which is what represents one element, a formula, which represents a combination of elements, and a equation, which represents a reaction going on. All right, moving on to page 196. Here's another equation. Iron plus sulfur yields, in the presence of heat, iron sulfide. Okay, and check this out. 14 grams plus 8 grams. So what is 14 plus 8? Any guesses? If you say 22, you're right on the money. Check it out. The weight of the reactants equals the weight of the product. There's no change. And that's what we're getting at right now in the conservation of mass. Another very important concept. Maybe even a great quiz question. Look closely at the values for the masses in figure 9. We just did that. Iron and sulfur can react to form iron sulfide. The photograph represents a principle first demonstrated by French chemist Antoine Lavoisier. Antoine Lavoisier in 1774. Woohoo! That guy was awesome. That looks like a good quiz question. Oh, I love it. All right. This principle is called conservation of mass, and it states that during a chemical reaction, matter is not created or destroyed. All atoms present at the start of the reaction are present at the end. Modeling conservation of mass. Oh, yeah. Moving right along. Conservation of mass basically means you end up with the same amount of stuff that you began with. Think about what happens when classes change at your school during the day. A class is made up of a group of students and a teacher together in a room. When the bell rings, people from each class move from room to room, ending up in different classes. The number of people in the school has not changed, but their arrangement has. Now, imagine that all the students and teachers are atoms. Each class is a molecule, and the changing of classes is a chemical reaction. At the end of the reaction, the same amounts of same atoms are present, but they are grouped differently. The amount of matter does not change. The principle of conservation of mass states that in a chemical reaction, the total mass of the reactants must be equal to the total mass of the products. That's the official definition. In your notes, you just might want to write that, or a quick summary if you can write it in a simpler way. Open and closed systems. At first glance, some reactions may seem to violate the principle of conservation of mass. Violate means to break or to go against, if you didn't know. It's not always easy to measure all the matter involved in a reaction. For example, if you burn a match, oxygen comes from the surrounding air. But how much? Likewise, the products escape into the air. Again, how much? Please move on to page 197. 197. All right. A burning match is an example of an open system. In an open system, vocab word, matter can enter from or escape to the surroundings. The burned out fire in figure 10, down here, is another example of an open system. If you want to measure all the matter before and after the reaction, you have to be able to contain it. Another vocab word, matter is not allowed to enter or leave. The pair decaying under the glass in figure 10 is a closed system. Okay? So, is a chemical reaction inside a sealed plastic bag. Ooh, yeah. Hey, that sounds like a good idea. I'll tell you what, if anyone wants to bring like a canning jar with a tight lid on it, let's put in a piece of fruit and watch it rot all year long. That'd be so cool. Okay, someone gonna bring it for me? I hope so. All right. Now, moving right along. this comes to the end of our video. I'd like you to please move to page 198. Thank you.